This is just a short video where I want to talk to you about the current coil relay lab, Lab 11A. Okay, Lab 11A is actually a troubleshooting lab. What I want you to see in Lab 11A is to see how to check the different portions of a current coil relay properly with your ohm meter. Now, I'm going to walk through the instructions here and then I'm going to show you a diagram of exactly what I'm sort of looking at on a schematic. But what we want you to do is get a current coil relay from your instructor. Now, current coil relays have a top side and a bottom side, okay? You'll stamped on the side of the relay, there should be either an arrow pointed up or the word up with an arrow. So hold the relay in an upright position. Put an ohm meter on M and S terminals of the relay. With the meter leads placed in the M and S terminals of the relay, that's your main and start, turn the relay upside down. Okay, these things are sensitive to gravity, and when you turn it upside down, the contact should close, and you should have continuity between M and S. This shows that the contacts are good. When you turn it upside down, if you have an infinite reading or OL on your meter, it means the contacts are stuck open, which would prevent the motor start winding from being energized. Replace the relay. As if the relay's standing in an upright position, and if you're getting continuity instead of an OL, then you also have a stuck contact in the closed position. So either way, you should have a continuity check when you turn that relay upside down and back. To check the relay coil with an ohm meter, okay, put a meter lead on L and M. Okay, if the coil's good, the meter should read an indicate of some ohm reading. Okay, if the coil is bad, it's going to be broken and it's going to give you an infinite reading or OL on your meter. Okay. Now, in terms of why you have to hold the relay upside down, because there's no spring in here. You cannot energize or manually close these coils or these contacts. So when you turn it upside down, gravity will close it and let you know it's working. In a current coil relay, it's the current or the amperage of the circuit that causes the relay coil's contacts to close. Okay, as with them open. When the start amps go up on the motor, okay, there's enough amperage being pulled to cause some magnetism on that coil. It's a very thick wire when you look at it, and that will actually get the magnetism. If the current coil relay is the only relay that is installed in series with the run winding. Okay, normally we never install another load in series with the run winding. This is your one exception. The coil on the current coil relay is at a low enough resistance that it doesn't make a difference. We're measuring current with it. Okay, if you have a capacitor, if you put a start capacitor in this circuit, the capacitor is going to be parallel to the relay coil because it's going off to the start winding, not to the run winding. If it were in series with the coil, it would be going to the run winding. So let's take a look at a quick picture here so I can point this stuff out to you. Okay, first of all, we said between L or M and S, okay, is where you'll put your two. So if I wanted to put 1 meter lead there and 1 meter lead there, okay, if I'm holding this coil in its normal upright position, and actually let me pull something out of it. Let's pull the motor out of here. Let's disconnect the motor really easily. Okay. If I'm holding my current coil relay in its upright position between M and L, I have a normally open contact. Now, when I turn this upside down, gravity will cause the contact to close, and I'll get a path of current to flow between M and S. I turn it back over again, okay, and gravity will open that contact. I will now have an OL between M and S. Let me get rid of my lines here. Okay, so, oops, that isn't what I wanted to do. Let's remove my motor again. And by the way, normally you'd remove the start cap also. Now, to check the coil, okay, as I just said on the when we were looking at the lab, to check the coil, I'm going to put 1 meter lead on L, and I'm going to put 1 meter lead on M. Okay, so I'm going directly through the coil. Okay, so between L and M, if I have a good coil, I'm going to have some resistance from the coil. If I have a bad coil, it just means there's a break in it or something, I'll have OL. So then, if we take and we put the motor back on, we can take a look at what we talk about series and parallel. Okay, the coil, which is between L and M, is in series with my run winding. Again, the resistance of my coil is low enough, it doesn't affect the voltage drop on the run winding. The capacitor is attached to my start winding. It's in series with my start winding, which means it's in parallel to my coil and my run winding. You see, it's next to each other. It's not a single path for electricity to flow. So hopefully that will answer some of your questions and explanation on Lab 9 or Lab 11A.